So example 9, the length in centimeters of a rectangular tile is a normal variable with mean 1.98 and standard deviation 0.1. The breadth in centimeters is another independent normal random variable with mean 9.8 centimeters and standard deviation 0.1. Firstly, find the probability that the sum of the lengths of 5 randomly chosen tiles exceeds 99.4 centimeters. So what have we got? Well, let's start by defining a few things. So let L and B be random variables denoting the length and breadth of a rectangular tile, respectively. So what do we have? The first question wants us to find the probability that the sum of the lengths of 5 randomly chosen tiles exceeds 99.4 cm. So that means if I take 5 tiles, L1, L2, L3, L4, and L5, I want to know the probability that these 5 exceeds 99.4 cm. So this is what I want to find out. Well, firstly though, we have to be a bit careful, right? What do we know? We know that the length and breadth are normally distributed. So each of these lengths, so L is normally distributed with a mean of 19.8 and a standard deviation of 0.1, so a variance of 0.01. And the breadth is again normally distributed with a mean of 9.8 and a standard deviation of 0.1, so mean of variance of 0.01 squared again. So what can we say about L1 plus L2 plus L3 plus L4 plus L5? Well, that's also going to follow a normal distribution, right? And its mean is going to be 5 times 19.8, or 19.8 plus itself 5 times. So 19.8 times 5 is indeed 99. And what about the variance? Well, because we're adding, I just add together all of the variances. So this is going to be 0.01 plus 0.01 plus 0.01 and so on and so forth. I get 0.05 to be my variance. So what is the probability then of L1 plus L2 plus L3 plus L4 plus L5 being greater than 99.4? Well, we look at our calculator. So we go and we want the normal, so distribution, normal CDF. And remember, it needs to be greater than 99.4, so 99.4 is my lower bound. My upper bound is a very, very big number. And my mean was 99, and my variance was 0.05, so my standard deviation is the square root of 0.05, and this gives me 0.0368 to 3 significant figures. Ignore that, sorry, I pushed the wrong button. So 0.0368 to 3 significant figures. Okay, good. So what about the second part? Find the probability that the breadth of a randomly chosen tile is less than 1/2 of its length. So what does that mean? That means that the breadth B is less than 1/2 times L, or in other words, that B minus 1/2 times L is less than 0. So what's the distribution of B minus 1/2 L? Well, I mean, let's start with the simpler question first. What's the distribution of minus 1/2? What's the distribution of 1/2 L? So let me get rid of all that Oops, let me get rid of all of that. Got rid of a bit too much there. What's the distribution of a half L? That's going to be normally distributed, and again we multiply the mean by a half. So where it was 19.8 before, it's now going to be 9.9. And what about the variance? We multiply the variance of 0.01 by a half squared, so a quarter. And we get 0.025 to be a new variance. Right. Well, what about b minus a half L then? So when this happens, what do? Well, we're going to add together the means. So this is now 9.9 plus the mean for b, which was 9.8. And that gives us 19.7 as, oh, sorry, not add. What am I talking about? Sorry, we subtract 9. So remember b, normally distributed with 9.8 and 0.1 squared. Okay, so we subtract 9.9 from 9.8 to give us the mean, which is minus 0.1. And with the variances, instead of subtracting, remember, we have to add them. So when we add these together, this number here, of course, 0.1 squared is actually 0.01. And sorry, I think I got this wrong. I think this is an extra 0 in here because the variance should be 0.0125. So, again, now that we've got this, we just need to find the probability that b minus a half L is less than 0. So that's the same thing as finding the probability that minus infinity is less than b minus a half L is less than 0. And so I can just do this on my graphing calculator using my normal CDF function. So let's clear that. Distribution, normal. So my lower bound was negative, and I'll use the right negative this time, negative infinity. My upper bound was 0. My mean was negative 0.1. And my standard deviation was the square root of, so remember I got the variance beforehand. So this number here, this number is the variance. So I don't want that, I want the square root of that to find the standard deviation. So I key all that in and I find 0.814 to 3SF is my answer. So 0.8143SF. Let S denote the sum of the lengths of 50 randomly chosen tiles, and T denote the sum of the breadths of 90 randomly chosen tiles. Find the mean and variance of S minus T. So again, remember that what we had the length is a normal distribution with mean 19.8. and variance 0.01 or 0.1 squared, and the breadth has 9.8, sorry, as its mean, and also 0.01 as its variance. So what is S actually equal to? It's the sum of the lengths of 50 randomly chosen tiles. So this is L1 plus L2 plus da 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 da. So I'm going to get bored, so I'm just going to pretend I've written them all out. And what does that mean? So how do we calculate this? That means that S is going to be, because it's the sum of normally distributed stuff, it's going to be the sum of, it's going to also be normally distributed. Its mean is going to be adding all of their means up, so that's just going to be 50 times 19.8. And then what about the variance? Well, again, because it's adding, I can just add them together directly. So the variance is also going to be 50 times 0.01. So in other words, S is normally distributed with a mean of 990 and a variance of 0.5. What about t? T is equal to b1 plus b2 plus all the way up to b90. So t, again, as the sum of normally distributed stuff, it's also going to be normally distributed. Its mean is just going to be 90 times the mean of all of these ones. So that's 90 times 9.8. And again, similarly, the standard deviation, the variance, because I'm adding all of these together, that means I can just add the variances together. So I'm going to get 90 times 0.01. So that means that t is normally distributed with a mean of 882 and a variance of 0.9. So what does that mean for s minus t? Well, so as you know, very well known, for s minus t, that will also be normally distributed. The mean, you subtract one from the other, so 990 minus 882, that's going to be 108. And what about the variances? Well, you add the two variances together, so that's going to be 0.5 plus 0.9, that's going to be 1.4. So, just knowing what we do, the expected value, let's call it, of s minus t is equal to 108, and the variance of s minus t is equal to 1.4. And that takes care of this question. Last one, find the probability that the mean breadth of 20 randomly chosen tiles is between 9.8 and 10 centimeters. So this is a little bit tricky, so what do? We start firstly by looking at what the distribution of 20 randomly chosen tiles is. So again, this will be normally distributed, and remember B has a normal distribution with mean 9.8, variance 0.01. So this one's going to have a mean of 20 times 9.8, and 9.8 times 20 is what? It is 196. And a variance of 0.01 plus 0.01 plus 0.01 20 times. So 20 times 0.01 is going to be 0.2. So this is the mean and standard variance of the sum of 20 of them. So what is the average, b hat? Well, that's just going to be 1 over 20 times b1 plus plus b20, right? So the distribution for b hat is what? Well, we're just multiplying a normal distribution, so we multiply, so it's still going to be a normal distribution, and it's going to be 1 over 20 times 196, and then for the variance, you still get a 0.2, but this time we have to multiply it by 1 over 20 whole thing squared, right? So this is going to be the distribution for our mean, b hat. So let's just work that out explicitly then. B hat is going to be normally distributed with the mean of 9.8, which makes sense if you think about it. The average is 9.8, so the average of the average should also be 9.8. But the variance is what? It is... Oh, sorry. Yeah, sorry. The variance is 0.2 divided by 20 squared. So 0.2 divided by 20 divided by 20 is 0.0005. So it's very small. 0.0005. I think that is right. Yes, and that's about 1 over 200. Or am I off by a... No, yeah, 1 over 2,000, sorry. Yeah. So that's right. So now remember what I'm actually asked in the question. I'm asked that what is the probability that the mean, that the average breadth of 20 randomly chosen tiles is between 9.8 and 10. So this is asking me the probability that 9.8 is less than b hat is less than 10. And again, I can work this out on my calculator. But I'm running out of time, so I'm just going to tell you. You go to the normal CDF and you find that this is 0.50023 SF. So any questions, please post them in the comment section. Otherwise, I'm out of time.